Hello class, in this video I'll be doing another example on how to find inflection points and how to apply the test for concavity. Let's begin. Alright, so we want to find the inflection points and any intervals in which the graph of this quadratic function is either concave up or concave down. And to do that, we're going to need to find the second derivative. So the first derivative is already provided, so the second derivative is just 2. And as you may recall, there are possible inflection points where the second derivative is equal to 0 or the second derivative does not exist. So if I set the second derivative equal to 0, what happens is that we get this false equality statement. So 2 never equals 0, so this is not true. Next, I'll make the claim that the second derivative exists for all values of x. And that's because the second derivative is equal to 2 for all values of x. Okay, so we have the second derivative never equaling 0 and the second derivative existing for all values of x. What does that mean? Well, that means that there are no inflection points. Okay, so now let's take a look at the domain of this function. So if we take a look at the domain of this function, the domain of this function is all real numbers because this is a quadratic equation or a quadratic function, okay? So since the domain of this quadratic function is all real numbers, there are no asymptotes and there are no holes. So the domain of this function is all real numbers. And since there are no inflection points, we're not going to break up this interval into separate pieces. So now, I'm going to pick a value of x in this interval. I'm just going to pick 0. And we already know that the second derivative is equal to 2 for all values of x. It doesn't matter what value of x I place here. I could place a 1. I could place let's go a -1. It doesn't matter. No matter what value I choose for x, the second derivative is going to equal 2, which is greater than 0, which means the second derivative is positive, which means the function, or the graph of the function, is concave up. So y is concave up over the interval -infinity to infinity. Basically for all real numbers. And that should come as no surprise, because if we take a look at the graph of this quadratic function here, this is a parabola that opens upwards. So that parabola is going to be concave up over the entire domain of the function. And let's go into Decimus. I've already entered the function into Decimus, and notice that it is a parabola that opens up over its entire domain, hence the graph is concave up over the interval -infinity to infinity. And we are done.